Hello everybody, today we are going to look at integration by substitution. We have learned there are some rules, right? The rules are the x to the power of n. So this is the rule, and then this is, if you have a constant, this is the rule, and then cosinus integration is sinus. You know that integration is antiderivative, the same thing. And at the end, all we just added plus c. So there are other rules over here. So there are other rules to do integration. However, they are not in your formula booklets. It's really hard to memorize. So what I'm gonna do, I am just going to cancel them and delete. I am going to teach you one of the methods, and use this method to apply the rules. This is called substitution. You can use this method for most of the questions. We can say all the questions. And then bring this question to those rules and then apply and find the integration. That's it. Let's start with the easiest part. For example, let's say the derivative of 2x plus 3 dx, right? Actually, we know that. So we can write it down. It's like 2x dx plus, and then 3 dx, right? And then we know this one over here, 2x plus, right over here, there's a 1 plus 1 divided by 2, okay? And then plus 3x plus c, okay? Alright, then these 2's are gone. What is left here? X squared plus 3x plus c. So this is the answer, right? This is the antiderivative. If you just look at it, this x squared derivative is 2x, right? 3x derivative is 3. That's it. And we always say we do not know the constant, which is 0. We don't know what is the 0. That's why we always add. That's it. Let's use my substitution method to do the same question. Okay, let's use it then. I am going to write the same question here again, 2x plus 3 and then dx. And I looked at this question here. What do you think? Is this, look at it here, is this any familiar one over here? Are there any familiar one? This one looks like this right here. This is something like x to the power of something. But right now I do not have x. I have 2x plus 3. You know what? Let's use the substitute. Instead of 2x plus 3, let's say u. And then make a derivative for both sides. Okay, make a derivative this side and then this side. This is the easiest method when you learn it, so you can apply it for every single questions. The hardest one sometimes, which one are you going to substitute? But don't worry about it. Okay, now I am going to make a derivative. When you make a derivative over here, this side, u derivative, what is the u derivative is? 1, right? Can I say 1 du? Because we need to write a du here. Otherwise, we can't use this substitution method. Okay, in just 1 du, 1 times du is du. That means the d stands here, just I made a derivative. That means the difference. Okay, and then here is the other part is 3 derivative is 0. 2x derivative is 2. 2, so respect to what? Dx, right? 2 dx. Is this okay now? All right, I want to make the, okay, let's, just a second now. Go to this here. Now what did we say instead of 2x plus 3? U, right? And then dx. There's a problem over there. We have u, but it says respect to dx. We do not have any x's here anymore. What I'm going to do instead of dx here, I am going to write what is dx is equal to. dx is, let's say, divided by 2. Dx is equal to du divided by 2, right? Okay. And then u times du divided by 2. You know what? I can make this one over here because this is a constant. I'm not dealing with it. Okay. 1 over 2. Okay. U du. Now look at it. What I did, I used the substitution method and I come over here. And this one looks like this one over there. Isn't it the same? I used the method to bring the rules. Okay, I knew that rule now. I knew this. It is equal to 1 over 2 is over here. Okay, u1 plus 1 divided by 2 plus c. Yeah. Okay. What is 1 over 2? What is the u now we said? 2x plus 3 squared divided by 2, right? And plus c. Okay, now 1 over 2. What is our u now? What is our substitution? We said it over here. So u is equal to 2x plus 3, right? Okay. And then instead of u, I'm going to write it down 2x plus 3. So 1 plus 1 is squared. It's over here. So this is also 1 plus 1, right? 1 plus 1. This is 2 plus c. Okay, let's continue. 1 over 2. So here is 2x plus 3 squared. Use the binomial formula. First term square is 4x squared plus 2 times first term times second term, which is 12x. And then plus 9 divided by 2 plus c. Now use the distribution property. When you multiply 1 over 2 times this, isn't it equal to the numerator part 1 times this is the same, 12x plus 9, and the numerator part 2 times 2 is 4, right? You know what I'm gonna do? I am going to write the denominator part every single term. Divided by 2, divided by 4, divided by 4, and then c divided by 2. Actually, this part I do not care. This is the constant part. What I did over here, for the constant part, I just write it down c, letter c, right? Then this is equal to 4 divided by 4 is 1x squared. 12 divided by 4 is 3x. And then here is 9 over 4 plus c over 3. So the whole thing is c for me. It doesn't, because there is no variable. There is no variable here. Just a constant. So isn't it the same right over here? We did it. And this. Yeah. But right now, the substitution method is a little bit longer than this. Right? Okay, but when you know it, it doesn't matter. You can apply it every single questions. Okay, now let's look at another example. Right over here, 8 divided by 2x plus 3. Actually, this is the question. I am looking at my rules here, this rule and that rule. Actually, these two rules are the same rule because there's an x to the power of 0 here. So you added 1 divided by 1 is the same thing. But actually, these two rules is the same thing. But now I'm looking at this question and then those rules. This question looks like which one of them? It looks like this, right? Then what I need to do, I need to bring my question like 1 over x or 1 over u, 1 over v, whatever. 1 over a variable. So you know what I'm going to do now? Instead of 8, let's write it down 8 times 1. And then instead of 2x plus 1, let's write it down u. And let's u dx. Now I have a only problem here, u and dx. There is a u and there's a dx. It says respect to x, but there's no x anymore. No problem. I am gonna make the derivative both sides here. This is 2 dx is equal to du, right? U derivative is 1, but this is respect to u. I just write it down du here. Okay, 1 times du is du. Okay, how about divided by 2? Dx is equal to du divided by 2. Okay, now instead of dx, let's write this one down. Okay, 8 times 1 u and then du over 2. And how about this 2 and 8 cancel? Here is 4 and then bring this out. So 4 1 over u du. Now look at it. This one looks like this. I know this 1 over x dx is equal to ln x. Now I know what does that mean. This is 4 ln u plus c. What is the u now? 4 ln, so u is 2x plus 1. 2x plus 1. So you can use the parentheses here and see. That's it. This is the answer. Let's look at another question now. Here is the hardest part actually. Which one I'm gonna say u substitute? Don't worry about it. Most of the questions, if this is that much hard, they say, please, this expression say u. Substitute this expression. I'm gonna show this to you later. But now, here is, I need to say this x. Actually, we always use, look at the degree. Which degree is this more? We said this is u now. So here is x squared and then here is 1. That's why we are going to say this is u. Alright. X squared plus 3x is equal to u. Make a derivative both sides. Then this is 2x plus 3 dx. Don't forget this. Du. Now look at it. 2x plus 3 dx. 2x plus 3 dx. Isn't it the same thing? It's like a puzzle, right? Okay, now instead of this, I'm gonna write u to the power of 4. U's and 4's looks like the same anyway. That's why I don't like u. Okay, instead of 2x plus 3 dx, I'm gonna write it down du. Look, now it's very simple. This one looks like right over here this rule now. I use the method to bring the rules. Okay, and now isn't it equal to u 4 plus 1 divided by 4 plus 1 du? Yep. Now just no integration sign. Just write u to the 5 divided by 5 plus c. What is u? We said u is x squared plus 3x. X squared plus 3x divided by 5. Don't forget the parentheses and 5 here, and then constant. That's it. This is the answer. Now let's look at your questions. Maybe some of you remember I gave you the rule over here and then I said that this is equal to something, but it's actually wrong. We made a mistake over there. Why? Because this one doesn't look like the rule. That's why I don't like the rules. I mean, that too many rules makes you confused, right? Okay, let's write this one down now. You can use the substitution rule. You can say 5x is equal to u. You always can use the substitution. But you know what I'm gonna do? Let's bring this 5 over there. Isn't it 5 over x? And then what is left here? 1 over x dx. Do I know this rule now? Yes, 1 over x, the integral 1 over x is equal to ln x. Okay, then 1 over 5 ln x plus c. That's it. You can use the substitution method. Now, I want you to look at those questions, okay, and then use the substitution method. Solve all of them. So no need to deal with tons of rules. As I told you now here, substitution methods. Look at it. What did I say? When it's little bit hard, they say by using the substitution this is the substitution method is given. Okay, let's solve this question very fast. Now this is u, then du is equal to 2 dx. Am I right? Okay, and then 6 divided by u dx. Now dx is a problem over here. Instead of dx, what I'm going to do, divided by 2. Du divided by 2 is dx. Instead of dx, I'm going to write du over, okay, 6 over u times du over 2. Okay, now 2 and 6 are going to cancel each other. So what is left here? 3 du over u. So I do not care about this 3. Put it in front. I'm going to go over here. 3 du over u. Actually, there's a 1 over here, right? 1 over u. Isn't it ln x? So that means 3 ln u plus c. What is the u we said? Substitution ln 2x minus 3 plus c. Please look at these questions. It's in your package, so integration package. What I know, isn't it so sinus x, integral sinus x dx minus cosinus x? Now, here the rule says x, your variable is x. Now my variable is 5x plus 3. That means I'm going to use the substitution method. There are other rules for this, but substitution method is the easiest one. 5x plus 3 is equal to u, then 5 dx is equal to du, and divided by 5, dx is equal to du divided by 5. Okay, now this question, now isn't it sinus u dx? Now I know the x is sinus u du over 5, right? Bring this 5 in front. 1 over 5 sinus u. Actually, I know this rule, sinus x dx is equal to minus cosinus x. Then this is gonna be no derivative sign anymore. Minus cosinus u. What is my u now? 5x plus 3. Okay, let's just write it down here now. Okay, this is equal to 1 over 5 minus 1 over 5 cosinus 5x plus minus 3, or just negative 1 times this, so cosinus 5x minus 3 minus divided by 5, and this is the answer. Please use use this method, substitution method, to solve all the questions. You can solve every single questions here, and then finish this package. And have a wonderful frohe Weihnachten.